Dear students, welcome to our class on JRF SRF Net 2022 Agricultural Meteorology Advances 5. In this class, we try to understand some of the processes that are occurring in the atmospheric boundary layer. So, centering around this drag coefficient, shear stress, Richardson number or Reynolds number. So these are the things that would appear in your exam in any form. Maybe in the interviews you may be asked, maybe in the bits, okay, multiple choices, or list 1 and list 2, and you pick up, you are asked to pick up correct answer. So in all these things, the questions may be asked in any form. So now let us try to understand what is drag coefficient. What is drag coefficient? Now, by definition, drag coefficient is a dimensionless quantity, that is used to quantify the drag or resistance. That is used to quantify the drag or resistance of an object in a fluid environment such as air and water. I repeat for your academic interest, bit may come like this. You should tick the answer for drag coefficient. So now, a dimensionless quantity that is used to quantify the drag or resistance of an object in a fluid environment such as air or water. Now, the drag coefficient of a wheat field which is at flowering stage, for example. What is the drag coefficient? It is a dimensionless number. How much resistance that the wheat field offers to take the required fluxes, moment of flux, mass flux, heat flux. So how much resistance is optimum for a wheat crop field? How much resistance is optimum for a wheat crop field to drag, okay, to drag the fluxes it requires. So to determine that, the drag coefficient is really useful. Now see, drag coefficient equation, drag coefficient theory I have covered in the micrometeorology. Still, drag coefficient we call it as capital C small d, drag coefficient. The factors affecting the drag coefficient, this may come in the form of bits in any way, okay. The factors affecting the drag coefficient are choice of the reference area. First one is the choice of reference area. That means a wheat crop of your PG or PhD experiment, okay. The choice of reference area, that's what we got as a capital A. Now shape, in which shape it is there? Most likely it will be the rectangular shape. Now then, the angle of attack. So what is meant by the angle of attack? The fluxes attack this particular okay, otherwise the quantities. What are the quantities? Fluid, air, fluid, whatever it may be. Sometimes heat, energy, so the angle of, from which angle the attack is there. For instance, in a crop field, the area, capital A, okay, choice of the reference area, shape of that particular field, and angle of attack. These are the three factors that determines the drag coefficient. Now, see, drag coefficient is also very much useful in agricultural equipment preparation for seeds. If you have harvested your PG experiment of wheat crop, okay, or rice crop, you wanted to take out all the grains that you wanted and leave the straw for the animal feeding. Okay, you wanted. So the drag coefficient is highly useful in making the tool, okay, for taking out the grains from the wheat or paddy crop that is harvested and separating it from the straw. So drag coefficient is useful. How? There are two methods of you can say that one is the dropping method, the second one is the suspension method. We use for what? Aerodynamic drag resistance and the terminal velocity can be calculated and measured by two methods. For what? In preparing the agriculture machinery for the seeds. To prepare agriculture machinery for seeds, two methods are used. Number one is the drop method. The second one is the suspension method. Drop method and suspension method. What is the drop method? This method involves dropping the material from certain height by which the material particles attain their terminal velocity, okay, for dropping certain distance. Suppose a wheat grain is there, you are dropping from this side. How much time it is taking to reach from here to here? That is the dropping method. Second thing is the suspension method. You take a vertical tube and then you allow the grain in it. How much time that the grain is taking to drop? Here what happens is that there are two terms involved here. One is the aerodynamic term. So you allow the wind to flow. Aerodynamic component, and the physical properties of the grain. What are the physical properties of the grain? The size, okay, the circumference or the total area of the grain. So like this, when you just drop through a vertical vertical tube and allow aerodynamic component, that is terminal velocity. What is the terminal velocity of that particular grain? Physical properties like grain dimensions, grain mass, projected area, how much of the grain area is there. So if you take these things, you can separate grains from the straw very easily, number one. Number two, different sizes of the grains also you can take it. Bold and big, usually we go for. Next, grains used for sowing, we call them as the seeds. This bit may come. Grains used for sowing, we call it as the seeds. So that means we can separate the seed from the material that can be used for consumption as well. Okay, so the drag coefficient, what is meant by drag coefficient is the resistance offered by an object. The resistance given, okay, projected by an object. We call it in a liquid environment, in a fluid environment, okay, in a fluid. It may be liquid or air. So drag coefficient is the drag or resistance of an object in a fluid environment. Okay, this is when we quantify it, that we call it as the drag coefficient. Now drag coefficient is equal to the drag force divided by the product of velocity, pressure and frontal area. How this drag coefficient is useful? First, in the beginning of the class I told, drag coefficient, it is a dimensionless quantity which quantifies the resistance offered by an object. For what? Resistance offered by an object in an environment of fluid. So, a fluid may be water or air. So, a crop field, how much drag? Usually, when there is maximum leaf area, there the drag coefficient will be usually more. Now, after this small beginning, we try to understand some bits with reference to friction velocity. This is there in your syllabus for PG and PhD. So friction velocity in the form of bits only we discuss. The theory I have covered in the Micrometeorology. That's why I request you please subscribe to our channel Agrometeorology, Farmers and Development. There I have given enough theory that friction velocity. This is an interesting term. What is the friction velocity? The bits become like the drag force per unit ground area has the dimensions of force per unit area. Okay, this is equivalent to a density multiplied by the square of a velocity. Density multiplied by a square of a velocity. What is it? Drag force per unit ground area has the dimensions of force per unit area. Say for example, you are going on the road, okay, with your some sort of moving wheels put over a wood, okay, wooden platform, like that's what we call in different languages, different titles are there. So you wanted to go on the road with some tool which gives you some sort of relaxing exercises. So the wheels are moving, you are standing on the wood. So when you go on the road, what will happen? You go on offering some sort of force, or you can say some sort of energy. So you are putting energy and then it is dragging you. It is dragging. So what happens is at such a level, the speed of the ground touching wheels would be slightly lesser than the energy that you put. That means you can, with your energy, you are going faster than the wheels that are traveling on the surface. So this is what we call as the velocity squared. Velocity squared. So that is where the word velocity squared has come. So here I would like to share with you that the density is that of the air in motion, in where frictional velocity, the density is that of the air in motion, and the velocity relates to the rate at which the horizontal momentum is transferred to the surface, and is often called as by three names. Once again I will read. By three names it is called. What is it? Eddy velocity, frictional velocity, shear velocity. Eddy velocity, frictional velocity, shear velocity. What is eddy velocity? What is frictional velocity? What is the shear velocity? Once again I read. The density is that in where the drag force per unit ground area has the dimensions of force per unit area. Now here the density is that of the air in motion, and the velocity relates to the rate at which horizontal momentum is transferred to the surface, and it is often called as the eddy velocity or frictional velocity or shear velocity. Shear stress rewritten in units of velocity, we call it as this bit may come. Once again, twice again I read. Shear stress rewritten in units of velocity is called as frictional velocity. Once again I repeat. Shear stress rewritten in units of velocity is called as frictional velocity. It is useful to know the velocity of a fluid in a stream. How the fluid is moving in a stream, okay, this can be arrived by frictional velocity. Now there is another small topic that I covered in the theory, that is the mixing length. In the bits form, I would like to remind you once again, at SRF level, or even during your write-up and even interviews in the competitive exams, it may be like this. What is mixing length? There are two words. Mixing length, MIXING, mixing length, and free path, FREE, free path. What is free path? If air molecules, they are colliding, constantly colliding each other, the mean distance between two collisions, we call it as the mean length. Similarly, what is mixing length? The definition will come in the form of bits, or you can say the application of mixing length may come in the form of bits. What is mixing length means? It is related to eddies, not molecules of the air. Mixing length is related to eddies, EDDIES. Now what is eddies? Eddies are the pockets of air. Okay, now what is mixing length? Mixing length is the distance that a eddy can travel without losing its basic characteristics, without losing its properties otherwise, before mixing into the environment around it. I repeat once again. First, free path. Free path is the mean distance that the molecules, air molecules or gas molecules travel between two collisions. What is mixing length? Mixing length is the distance traveled by eddies by retaining their properties before they get dissolved in the environment and losing their characteristics. That is in the form of bit. It may come like this: a distance that fluid parcel will keep its original characteristics before dispersed them into the surrounding future is known as mixing length. Similarly, mixing length is also asked like this: the average distance that a small mass of fluid, the average distance that a small mass of fluid will travel before it exchanges its momentum with another mass of fluid. I repeat once again for your academic interest. The average distance. What is mixing length? Mixing length is the average distance that a small mass of fluid will travel before it exchanges its momentum with another mass of fluid and loses its characteristics. Now, another way a bit may come like this. Okay, now mixing length assumes that. What mixing length concept assumes? It assumes that a lump of fluid retains its identity over a certain distance. Okay, a fluid retains its identity over a certain distance, after which it loses its momentum to the surroundings and adopts the properties of its environment. So there it is getting mixed. Problem and fluid is there, lump of fluid is there, it can retain by traveling to after some time with its environment. Okay, it gets dissolved and loses or gains the properties of the environment, loses its own properties. So that means the distance in the transverse direction which must be covered by a lump of fluid particle traveling with its original mean velocity in order to make the difference between its velocity and velocity of the new layer. Okay, this statement also may be asked. Two layers are there. The distance to be traveled by this layer, this lump of fluid into another layer, but before it loses all its characters is also known as a mixing length. This is what I would like to share with you in this class, and in the next class we try to understand some more things. Thanking you very much for your very patient hearing.